Okay, so welcome to our second exploratory activity for conic sections. The first one was parabola, and so now today we're going to be working on a different conic section. So the first thing we're going to do, I'm going to walk you through the instructions here on page 1. We're going to draw and cut from paper a circle, and we're going to label the center O. So I'm going to use my compass, and I'm going to use my compass and create a circle. Oh, it is not the day. Okay, try again. There we go. Okay, there we go. We have drawn a circle, and I'm going to cut it out real quick. And you'll notice that this says to work in pairs. Obviously, because of COVID regulations, you cannot move and sit together to work in pairs. The idea behind that is that you're going to want to compare your figure with someone else's. So just the person next to you, the people next to you. I've done this activity more than once, so I've got an extra one that I can use to show you what you're looking at when you compare them. Now that I have my beautiful little circle here, I'm going to take my marker and I'm going to mark the center O. Okay, so then I want to locate a point F that is inside the circle but not at the center. Some of you need to put F closer to the center, some of them farther away, because it's going to change the shape we're looking at. So I'm actually going to put this one fairly close to the edge. So we want to fold the paper circle so that the circle curve coincides with F. In other words, we want to take and we want to put the edge of the circle on point F, and we're going to crease it. And we're going to do this 20 to 30 times by moving F along the circle. So see, I've done it once, and then I'm literally just going to kind of rotate my circle a little bit and do it again. I would not put F this close to the edge. It does make it a little more cumbersome to try and get these folds in. So that was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, I'm looking and I can't really see a shape in here, so I'm going to keep going. There's 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so now hopefully when I open this up, okay, we can kind of just barely see the shape. It's really clear right around in this area. It's a lot less clear up here. This is obviously not perfect in the least. But okay. So now we want to locate 2 points P and T on the curve. So P and T, we really don't care where they're located. So then we want to first fold our figures so that both O and F are on the fold. So we want to fold this, let O and F are both on the fold. So it's going to be just like that. And then we want to fold again in half the opposite direction. So that would be like this. Okay. So now the first question we're asked is what figure is formed by the creases? So when we're little, we learn this maybe as an oval. When we're talking conic sections, though, we're going to call this an ellipse. So this is an ellipse. Now it wants us to find some measurements. Oh, and I forgot to fix this on your worksheets. Oh no, it's the other one. Okay. Yeah, okay. These are good. My apologies. So the first thing we're going to do is measure from we're going to measure from P to O. So from P to O, if I can get this lined up correctly. There's 1, 2, 3 sixteenths. And then we want PF. Okay. Here's F and here's P. And that's 1, 2, 3, 4, 5, 6 over 16. So then PO plus PF, I'm going to work ahead a little bit, is going to be 1 and 9/16 inches. Okay, now I want TO. So starting at T, we're going to measure down to O. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sixteenths. And then from T to F, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, looks like it's between 11 and 12. We're going to go with 11 sixteenths, which is 25 over 16, which is 1 and 9/16. And so how do these compare where they're equal? My black pen is not showing up very well. Okay, so they're equal. So what points seem to be the foci of this curve? Well, if we look, F and O seem to be the foci. Everything seems to be based off of F and O. Now, what happens to the flatness of the curve as F moves away from O? Well, if we look at these other examples that I've done, so for example, I have this one that I did, which is almost circular. Notice that this one that we've just done over here on the left is much flatter than the one that I'd done previously where F is closer to O. So as F moves away from O, it gets flatter. So the fold lines are both axes of symmetry. The longer axis is called the major axis. So this would be my major axis. Oh, that purple doesn't want to show up. So highlighter does not work so well on the wax paper. There we go. That's my major axis. The shorter axis is called the minor axis. So this would be my minor axis. Let me move this one out of the way. We're not working with him. Okay, so fill in the blanks to complete the following definition. An ellipse is defined as all points in a plane such that the sum of the distances from two fixed points to a point on the locus is constant. The two fixed points are called foci. So now on the back, they give you our standard form of the equation. They ask us to label the center of our ellipse as HK. So that's going to be this point right here is HK. The distance from the center to the vertices is A. So this is A, and this is B. Sorry, this goes all the way out to the end, not to F. The distance from the center to a focus is C. Now, using that information and following the directions that they give you, you're going to use your critical thinking skills to determine some formulas and equations, and we will formalize it tomorrow. Good luck.